Morning, everybody. Today we are going to have a different topic from the usual routine dermatology topic. It's not the one which you are going to hear from Dr. Sebastian. This is, in fact, a purposeful choice because as postgraduate students, you are compelled to read a few journal articles. But you have to read journals continuously all throughout your life. But the problem of reading an article is that it is not the word which is written on the pages is important, but it is more that is written on the pages, and then hidden knowledge that is in the article is more important. In order to know what is written in the page and what is behind or in between the lines, we need to tutor ourselves how to read an article. Dr. Sebastian is a well-versed person of analyzing the journal article. She has studied in Harvard, her basic statistics, and then went to the higher studies. Later, she did her MSc Dermatology, and finally, now she has completed her membership in UK. So, and to say about Dr. Sebastian, she is a very talented young dermatologist. By now, she etched a very significant title in her career. And she is one-time recipient of the National IADVL Best Thesis Award and all. So many things she had achieved. And I am sure that you will be benefited from her talk. Over to Dr. Sebastian.
Thank you so much, sir. So first of all, I would like to extend, I'm very grateful for this wonderful opportunity to teach students, because teaching is always a passion. And thank you so much, sir, for that introduction. So since we have only very limited time and we have a quite a intricate topic, I'll be directly going to present the topic today. In case you have any doubts, you're more than welcome to put in the chats. You can ask the questions, raise your hands, and at the end, we can probably discuss in case you have any extra doubts. So I'll once again, thank you so much for the opportunity. So I'm just starting my presentation. So I think today's topic, as sir has already mentioned, is quite tricky for many people, especially as medicos. For us, we are taught about the medical subject a lot, but we are taught quite less about the medical research and how to interpret and how to do a research study. And it's quite a requirement while you do your study and you do your post-graduation, and even after that we have to go through a lot of research articles, and we also need to do a lot of studies. So that becomes quite difficult. So let's see how we can break down these into simpler steps so that it can be something that everyone can do it at their work or during their studies and everything. So what is that you need to look for when you interpret the research papers? So the first thing that you wanted to see in a research paper is there any established association? If yes, is the association significant? And if significant, is it scientifically explainable? So these are the three main questions that you need to have at the back of your mind before you read an article. So when it comes to the research studies, we need to look at the validity. Validity stands for how good is a study. So this validity is actually divided into two. One is the internal validity and the second one is the external validity. So the internal validity stands for how good the study is being conducted, and the external validity stands for how far we can extrapolate these findings to the population. Probably the population that you're treating or the population of your place, etc. So first, I'll help you to delineate the internal validity. So before that, let's go to the basics on how the research studies are being done. So generally we have two groups. So one group probably have an exposure and have an outcome. And we are probably looking if the unexposed group also has the same outcome or is it significantly different. In an ideal situation, we actually need a time machine to go back and have the same group who have got the exposure, not have the exposure, and then come forward and view the outcomes to see if it is really due to the exposed. But as we all know, this is actually not possible in a regular scenario, which is why we go for our control group, which probably don't have the exposure or which probably don't have the disease that we are looking for. And then we analyze what their exposures were or what their outcomes were. So, and the main problem in research studies is while choosing a control group, because it's quite difficult to get a control group which is a replica of the exposure group or the case group that we are looking for. So I'll give you an example of tossing a coin here. Imagine you tossed a coin. So you are comparing the probability of two coins. And imagine first while you toss a coin, you got 5 heads and 5 tails. So you'll be like, that's normal. That's a probability that you're expecting, that 50% chance for head and tail. Imagine you tossed a second coin and 9 times you got head and 1 times you got tail. So that is when you start to think, is that real? Do we get like that? Or is there something else that has contributed to that difference? So imagine we are looking at probably we are trying to evaluate, is it because the physical structure of the coin has varied that in the second coin we got 9 times head and 1 time tail? So imagine that is a question that we have. So one thing is that there is an actual difference between these two coins, probably physically, due to which the second time you got 9 times head and 1 time tail. The second thing is that it can be due to chance. It also can be that when you tossed a coin, 9 times you got head, it's not because of any structural variability, it is just due to chance. That's also possible, right? And the other factors that you need to delineate is there any possibility for bias or confounding that has resulted in the coin having 9 times head and 1 time tail? For example, imagine while you toss a second coin, there was a direction of the wind which actually caused 9 times head falling, instead of it being a cause of a physical structure of the coin. Or imagine that it's probably because it is a second observer who tossed a coin and there was a particular way he tossed a coin due to which the 9 times the head has fell. So this is what you need to keep in mind in every study. So in every study, when you do and when you see a difference, it can be an actual difference where there is a structural problem with the coin that has resulted in the difference. Second thing, it can be because of chance, mere chance that it happened. And the next factors is bias and confounding. As a factors I mentioned, the direction of the wind or because of the observer tossing the coin in a particular way that you got 9 times head. So this particular thing, you can keep in mind that you can apply it to any studies that you see. So when you have the study results, you can keep in your mind, it can be actual difference. But before that, we need to rule out the fact that it can be because of chance, it can be because of bias, it can be because of confounding. So this is where the critical evaluation of research comes. Now, so this is actually divided into two things. One is random error and the next one is a systematic error. So the random error is basically the error that you get due to the chance. As we mentioned, the fact that you got 9 times head can be purely because of chance. So that is a random error. And the systematic error is bias and confounding. The fact that the wind blew in one direction or because of the observer. So that is systematic error. So these are the two errors that you need to evaluate while you look at a research article. So now this is like a pictorial representation how the errors can vary. Imagine this is like a target and you're throwing the arrows or you're shooting bullets. So the first picture is where there is no error, where there is accuracy and precision, that everything has fallen rightly in the target. The second picture is where the random error comes, where you have accuracy. Everything has fell in the center, but as you can see, it's not close together. So there is a lack of precision. So that is where the random error comes. And the end, you have the systematic error, where you have the accuracy, and where you don't have the accuracy. As you can see, all the points are in one end, but you have the precision because they are grouped together. So this is the 3 different types of error, 2 types of error that you get in your research studies. So I think so this, I have put examples so that it'll be easier for you to understand what I'm trying to tell. So let's look at the study. So this is one of the studies that's been done in lichen planus pigmentosus. So as you can see, the aim is basically to delineate the clinico-etiological profile in lichen planus pigmentosus patients. Let's look into the methods. What you can see is there's a total of 100 patients that have been diagnosed with LPP, and they're trying to delineate the demographic details as well as some other factors like what they have used. So let's look at the results. So what they have seen is they have taken 100 patients and they have set the proportion of number of males and females that they have got. And then as you go down in the paragraph, you can see that they have mentioned certain proportions. What was their common complaint? What has they used? For example, topical mustard oil, hair dyes, everything. So what you can see is they have mentioned certain percentages of the occurrence. Okay. So can someone in the group tell me what kind of study this is? You can just put in the chat or you can raise your hands. It's okay. Okay, so I think I'm not seeing much response. So anyways, so this is basically a cross-sectional study where at a point of time, you're looking at the proportion of the patients who's having all these factors. But what I would like you to focus at the end of the results, where they have mentioned a positive association was found between hypothyroidism with diffuse lichen planus pigmentosus, where p-value was less than 0.01. Now, so probably we can, at this, we probably might think that probably there is an association between hypothyroidism and lichen planus pigmentosus. And you saw the p-value was significant, less than 0.01, because we know p-value becomes significant when it's less than 0.05. And even this is one of the main ideas which I had when I didn't have much research knowledge, that if the p-value is less than 0.05, that association is significant. So there are a couple of things that you need to keep in mind here. So what does a p-value mean and how does it rule out all the errors that you have mentioned before? So as I mentioned, this is a case cross-sectional study. So this is a pyramid which most of you might have already seen, where the significance of the studies is being put up according to their significance again. So there is two types of studies. One is descriptive and the other is analytical. So descriptive study is when you're simply describing what you're seeing. For example, the case series, the case reports, maybe some expert opinions. So all these, even a cross-section study is a descriptive study mostly. Whereas what is analytical study is where you're analyzing the association between two factors. So that can be case control, it can be cohort, it can be RCTs, and systematic review is a review of all these studies. So which is considered to be of much more higher importance. So this study was a descriptive study. As you've mentioned, they just mentioned the proportion of the patients, right? And they only have taken lichen planus pigmentosus patients. There was no control group in the study. So if imagine you're only taking smokers, or imagine you're only taking lung cancer patients and you're assessing the number of smokers in that. And imagine at the end of the study, you're saying that smoking is associated with lung cancer. Is that right? Probably it's right because we know it's well wide established that smoking causes lung cancer. But in order to establish the association, we actually wanted a group of patients who did not have lung cancer, and we actually had to look at did they smoke or not. We wanted these two groups and we had to look at their outcome and compare these two to tell that smoking caused lung cancer. Actually, that is how you analyze a study. And so let's go back to the study. And in this study, it was just 100 patients of lichen planus pigmentosus. There was no comparison group to say that the outcome is different in these two groups. Okay, what if we took patients who did not have lichen planus pigmentosus and we had the same proportion of patients with hypothyroidism? In that case, we say that no, hypothyroidism is not associated with LPP. So as far as you have not compared these two groups, you actually cannot say that these two things are associated. So that is where the analytical studies come in. So every study requires a lot of work. I'm not here to scrutinize the studies, but I just wanted to point out that these are the things that you need to look for. So as long as you have not taken a control group and assessed how many people have hypothyroidism in that group, you can actually not say that there is an association between these two parameters. And here they also haven't given a value of what is the association. Is it 2 times that you see that lichen planus pigmentosus patients have hypothyroidism compared to normal? Is it thrice? Is it 0.5 times? So they haven't mentioned that measure of association. As we move down, I'll tell you about what is measure of association, how to calculate. So you need to tell what is a measure of association, and then you also need to tell what is a p-value. So p-value actually stands for the probability of an event. So it actually requires a bit of background. So p-value is a probability of an event under null hypothesis. So I'm not getting into too much detail because it will be difficult. So to understand p-value, I'm simplifying it as p-value is the fact that probability of occurrence of an event due to chance. So I'm again going back to tossing the coin example. If you tossed a coin and you got the difference, and the p-value of that probability due to chance is less than 0.05 or less than 1 in 20 chance that the chance factor is very less. Probably there was a difference in the physical structure of the coin that has resulted in the result that you have seen. So I hope you understood what is the meaning for the p-value. So let's go for the materials and methods now. So at the same study, I'm just reviewing. So in this, it just mentioned that it was a hospital-based prospective observation study with 100 patients, and they haven't mentioned about any control group. So there was no control group. And in order to evaluate this p-value, what you need is, you need a statistical test. There was no mention of a statistical test. So without mentioning what statistical test they used, without having a control group, you cannot actually say that there is an association. I hope now you better understand the things about p-value. So when you want to address the random error, so in a study, you have random error, you have systematic error. In order to address the random error is what we are looking for, p-value. In order to calculate p-value, you need a statistical test, which I'll tell you in the upcoming slides. And p-value indicates that it's not due to chance. Still, the result can be because of bias. It can be because of confounding. In the tossing the coin example, it can be because of the wind, it can be because of the person who have tossed. So all these factors you need to again address while evaluating a study. So how do you address that? You will have to read the methodology in very detail. See if they have mentioned that the same observer has tossed the coin. See if they've mentioned that the tossing the coin was done under the same environment. So all these rules of the chances for bias and confounding. If all those are ruled out, then yes, there is an actual probably a physical difference in the coin that has resulted in the difference. Otherwise, your result is actually not valid. So we have addressed the p-value is basically addressing the random error. It indicates a probability of an event is not due to chance. Probability of an event is very less due to chance that it's likely something else has resulted in the difference. So p-value is the probability of an event due to chance. So this is actually the steps of hypothesis testing, which actually I'm not going in very detail because it will take quite time. So in any study, this is actually required to assess the p-value. So you need to know what is your null hypothesis. You need to state the type of data. I'll just show you how you need to state the type of data. And then you need to determine the statistical test. At the end, you should understand the statistical test is actually for calculating the p-value based on which you reject or accept your null hypothesis. So this is actually an example of what is a variable. So what is a variable? You need to know that. Variable is something that you measure. For example, in the case of smoking and lung cancer, the smoking is a variable. Lung cancer is a variable. So you need to measure these variables. So variables can be different types. For example, if it's smoking and lung cancer, it is you can smoke or not smoke. So that is called as a binary variable or dichotomous variable. You can have lung cancer or no lung cancer. So that's again a dichotomous variable. As you can see in the table, the second box is a dichotomous variable. It can be continuous variables. For example, if you are assessing age and probably cancers. So age is a continuous variable. It can be range from 1 to 100 or whatever age it can be. And if it's height, again, it's a continuous variable. We also have nominal variables, which is gender and race, for example, male and female, or it can be black and white colors, etc. Ordinal is when there is an order, for example, moderately severe, very severe, mild, etc. So these are the variables that you need to keep in mind. So next about the statistical test. So you need to choose the right statistical test. So I'm not going to explain the whole table. but you can have a look at what statistical test that you can use. So if you look at the table, we are having, if you're taking smoking and lung cancer, it is binary variables, both of them. So outcome and predictor is binary variable. So in that case, what is a statistical test that you can use? As you can see, it is chi-square test. So if you want, you can take a screenshot of this, because this says which statistical test is to be used according to the variable. And because of time constraints, I can't go through all these statistical tests, but these are the tests that you need to do for analyzing the p-value and the association. And it varies with parametric and non-parametric data. So parametric data is the first one where there is a linear curve, and non-parametric data is when it is split. So these are the type of studies, as you've already mentioned. Your descriptive studies are basically to come to a hypothesis, and analytical studies are basically to measure the association. So I hope you have understood what is p-value, what are the what is meant by a statistical test, and what actually you're evaluating in a statistical test. Now coming to what is an outcome measure. So for example, you're taking lung cancer as an outcome. So that is the outcome. So that's a variable. We need to measure that variable. So we have certain outcome measures. So if it is a dichotomous variable like lung cancer, we do proportion. How many patients, for example, who have smoked has got lung cancer? Imagine 100% smoked and 50 got lung cancer. The proportion will be 50%. So that is proportion. And when it comes to the continuous variables like age, it is mean. For example, we say the mean age of the group is probably 60. If it's a age that ranging from probably 50 to 100, and mean was around 60. So that is for the continuous. So that is an outcome measure. Now, what is meant by measure of association? So if you take two groups, one exposed and non-exposed, extent to which the outcome increase or decrease than would normally happen in a non-exposed group. So imagine you have a non-exposed group, you have an exposed group. How much is the outcome more in an exposed group compared to non-exposed group is what we call as measure of association. Okay. So what are the different measures of associations? So it can be absolute difference or it can be relative measures. So absolute is, imagine people who smoked had lung cancer of 100 and who didn't had 50. So 50 is the absolute difference between the two groups. And what is the proportions? Like relative risk can be ratios, like it can be 1 by 2. So that indicates that it is half the proportion. So that is a risk measure. So there is two types of measures of association. One is the absolute difference and the relative ones. So the relative ones includes rate ratio, risk ratio, odds ratio. So odds ratio is the main measure of association in case control studies, and the risk ratio is the main association in cohort studies. And you have the difference measure. So these are, so whenever you read a study, when they say it's associated, you need to look for which measure of association have they measured and what is a p-value. So these are the things that you need to check when it comes to the measure of association. So again, coming to checking the internal validity, we are checking the internal validity. We have ruled out that probably if the p-value was very less, it's not due to chance. But still, as I mentioned before, we have two things to assess, which is bias and confounding. So let's see what are the different types of bias that can happen in a study, what are the different types of confounding that can happen in a study, and how it actually affects the results. So coming to the bias, we have selection bias and information bias. So selection bias is how you select the individuals into the study. So when you read the methodology, you need to check how they have selected the study population, how they have selected the cases, how they have selected the controls. And then when it comes to the information bias, you need to check how have they collected the information, how they have measured the exposure, how they have measured the disease. So that is information. So if there is any error in the way they've selected the people, if there is any error in the way they have collected the information, that can result in a bias, which can actually result in a spurious association, or it can mask an association. So you need to look for what are the different types of bias. I'll just quickly go through the different selection biases that can happen. So it mainly happens in case control studies where you are assessing, for example, you're taking, again, let's do lung cancer. So in a hospital, you're taking people with lung cancer. Or let's say you're taking people with pancreatic cancer. and you're assessing smoking as a reason for pancreatic cancer. And then, or let's take a GI ward, so gastro ward. So there probably you're having pancreatic cancer, you're assessing coffee as a cause for pancreatic cancer. And as a controls, imagine that you're taking gastritis patients. So they don't have pancreatic cancer, but they do have gastritis, due to which probably they might have restricted the coffee intake. So the exposure is actually not normal, right? Probably they've reduced the exposure of coffee. Normally they would have had more coffee, which means the exposure is actually going to vary between the groups. Ideally, the controls should be an exact representation of the source population, which means the gastritis patients are drinking less coffee than the normal population. So that is actually creating a difference. So they are not ideal representation of the population. So that can result in the difference between these two groups. So that can again affect your results. So that is selection bias. So let's take the study and see how they have addressed this. So this is a study where lichen sclerosis has been taken as a disease, and they have tried to identify the risk factors. And as you can see in the method, they have taken as controls 3 age-matched population control for each case. So one of the main method by which you can actually control for this kind of bias is when you increase the number of controls and when you've taken the controls from the population-based sources. So that's been done in this study. And coming to, again, this again shows how they have blinded with the codes, patient codes. So that's again useful for a certain type of biases, which we will deal in detail. So one selection bias is how we have selected. Again, in cohort studies, what can happen is you can lose the patients on follow-up. If it's a long follow-up, say for many years, you can lose the patients on follow-up. So this actually result in, again, a bias, because that's not the classical way you will have the results, because you have lost many patients. So this loss of patients can be because they developed the disease and probably they died in between, or it can be normal. So if you lost equal number of patients from these two groups, it's okay. I mean, it will balance out at the end. But if only the case group or the exposure group is having more loss to follow up, that can result in a bias. So any change in these two groups can actually result in this bias. So now, how do we rectify this? That's a question. So the important thing about bias is you need to address the bias while designing a study, because it's difficult to address the bias in the analysis. So you need to choose the comparison group carefully. The control group should be very carefully chosen. You need to do standard follow-up procedures so that you actually don't lose the patients on follow-up. And then you also need to obtain any backup contacts in case you lose any patients. So that's all about selection bias. So selection bias is a bias has happened while selecting the patients into the study or while analyzing the patients. Now, what is information bias? So I think this is one of the most biases that everyone knows. One is recall bias and the other is ascertainment bias. So recall bias is probably the lung cancer patients remember more about their smoking than the patient who don't have cancer. So that is recall bias. And what is ascertainment bias? For example, in a case control study, I know that smoking causes lung cancer. So probably I'm going to closely observe the people who smoked if they develop lung cancer. So that is what we call as ascertainment bias. So this bias happens while you collect the information. So how do you, so this information bias is also called as misclassification. And how do you address that? You need to use a validated measure. You need to rely on the records. You need to mask the hypothesis, which is what we call as blinding, which is what everyone knows probably. And we also need to do standard follow-up procedures. Now let's do what is confounding. So confounding is a factor. Confounder is a factor which is associated with the exposure and the outcome, which has an influence on the outcome, and that is distributed differently across the exposure, across the two groups. So this is a confounder. I think this will be the easiest graph to identify a confounder. Confounder is something that's associated with the outcome or has an influence on the outcome, is also associated with an exposure. For example, imagine smoking causes gastric cancer, and we are taking coffee consumption. We know probably smokers also consumes coffee, so they have an association. And the outcome is cancer. So even coffee has an influence on that. So that is confounder. So the problem with the confounder is if two groups don't have equal confounders, they are going to produce different results. So that is the problem with the confounder. So confounder can be addressed in design and analysis. So in the design, we have methods like randomization, restriction, and matching, where the randomization helps in taking patients randomly from the group. So that helps to balance out the confounders. That's been already established in different studies. And restriction is that, for example, if you think age is a confounder, I'm going to only do under 50 age group, or I'm only going to do above 50 age group. So that is restriction. And matching is when you match the two groups with the confounder. For example, if you're thinking coffee is a confounder, you're going to take the exposed and the non-exposed both having coffee, so that that is not going to make the difference in the outcome. And confounder can also be assessed in the analysis. So that is stratification, regression, propensity score matching, instrument variable analysis. I'm not going to detail because it's a bit too statistical and the time is quite limited. So let's take the study. This is another study that's been published. So this is the efficacy of abrocitinib in moderate to severe atopic dermatitis. As you can see, the methodology is highlighted that this is a randomized study. So probably they are addressing the confounding. It's a double blinded. So they are addressing the bias. It's a double dummy. Again, that's a type of blinding where imagine one is a tablet and the other is injection. You're giving a dummy normal saline injection and then you're giving a placebo tablet. So that's called double dummy. It's again controlled parallel treatment, which means we give controlled treatment, parallel treatments. So this is a very good way of addressing confounding and the biases that we have mentioned already. And so this is again the same study. I'm just reading the methodology to show you how they have addressed things. So this, as you know, is a treatment for atopic dermatitis. So probably the patients might have received a lot of treatments before. So how do you address that? So systematic treatments, they've mentioned that were required to be washed out during the screening period. So they've given the time for the medicines that have already been given to go out of the system so that that's not creating the effect. So what is that? That is again, they're addressing the confounders because that particular drug, like methotrexate, probably is used for atopic dermatitis and probably has an influence on the outcome. So that's a confounder. So they have addressed the confounder. So this is how actually you need to get into the methodology part and see how they have addressed the bias and the confounders. So now that we have finished the internal validity, where you're looking for the chance factor using p-value statistical methods, we're thinking about the bias and the confounding. Next thing that you need to think about is the generalizability. To whom can I apply the results? Imagine a study is being done in children. Can you, or in adults, can you extrapolate that to children? No. Imagine a study is being done probably in an Asian population. Can you extrapolate that to a Caucasian population? Probably not, because there is an influence for genetics. So that is where the generalizability comes into play. But probably you can take that hypothesis and then do the study, but still you can't actually generalize. So we have actually finished the whole portion on how to interpret research papers. I think if there is one takeaway that you need to think is p-value is just not enough. So we need to address a chance, we need to address a bias, and then we need to address a confounding. So I think we have crossed the time a bit. So I'll be going quickly to how to formulate research papers. So I think as a postgraduate or as a medico, in the initial phase, the main problem that you will have is what topic do I choose? So that is the main problem because you don't know what's been already established, what are the different things that already have a lot of evidence and what don't, what do you study, what topic on do you. So the easiest method to do that is you go for the research papers, especially the review literature or already established guidelines where they would have mentioned about the gap. For example, they would have written, there is no enough studies on this particular topic or area that we can't come to a conclusion. That is where you should do the study. So that's how you can actually design studies in your early phase. So another thing that you need to look for is, are you making a good contribution, or is my study adding something to the topics that's already established? So that's something that you need to have in your mind. So you need to do experts. So as I mentioned earlier in your career, you need to look for review articles, the guideline statements. And if you want to know if there is any trials that's been already done, then you go for clinicaltrials.gov, where you can look up what's the trials already been registered. So one of the helpful measures when you do a protocol preparation is what we call as PICO method. So what is PICO method? You need to properly define what is your research question. So I've put some example here. Imagine you're going to look at the effect of dupilumab. So the population is probably children with moderate to severe atopic dermatitis. And what is your intervention? I stands for intervention. It's dupilumab. What's your control group? Probably the moderate to severe won't be without any treatment. So probably let's take that they're on cyclosporin and you want to see the difference between these two. So your control group is moderate to severe atopic dermatitis on cyclosporin. What's your outcome? That is improvement of atopic dermatitis. So the PICO method is something that you can keep in mind to be very clear on what your topic is, how you need to prepare a protocol. And we always establish in the protocol the null hypothesis, where we say there is no difference between the two groups. For example, if it's a dupilumab and cyclosporin, the null hypothesis is that there is no difference between these two drugs. Obviously, that's not what we want to study. We want to see the alternate hypothesis, which is there is a difference. So this is how you formulate a research paper. You need to see the design, and while you do the study design, you need to keep in mind the possibilities for the bias and the possibilities for the confounder. So if you're not aware of what confounders can be, you need to do a literature search where they would have mentioned the same disease having been influenced by certain factors. So you can use that. And then again, from the picture which I showed earlier, you can see what is a variable you are measuring. Example, in this case, it's dupilumab and atopic dermatitis. So again, it's a dichotomous variable. So what statistical test would you use? What is a p-value? And so is that significant? So that's how you need to design your study. You will need a statistician in order to get the sample size, which is what we call as a power. And you also will need the statistician to probably in the early phase to say about your statistical test, how it can be done and everything. But you will need to contribute very much because statisticians won't have much knowledge about the medical part. So that is where you need to help them out. So if you have some basics in mind, you probably can help them. Otherwise, when the statistician say something, probably you won't understand, or probably you won't be able to put in your thoughts and your ideas into your research study. So before we end, I would like to tell you about the errors that can occur in your study. So often we hear about type 1 error and type 2 error. So what is type 1 error? As I mentioned that we say it's not due to chance when the probability is very less than 1 by 20 or 0.05. Still, there is a probability that it can be chance. It can be due to chance. So this is an arbitrary value that's been chosen by probably the statistician before and the the research field, that this is the arbitrary point. But still, there is a possibility that it can be due to chance. So type 1 error is when you got a result, but it's due to chance. Type 2 error is that you are not actually detecting the real difference. For example, you say there is no difference, but actually there was a difference. So this can happen when your sample size is not sufficient enough. So which is where you need power. So the sample size should be sufficient enough to detect the difference. That's what we call as power. So this can be addressed by increasing your sample size. So that actually brings us to a conclusion of the topic that we are supposed to address today. But I would like to conclude my lecture with this topic, what we call as thinking. So I think as medicals, we are programmed to think in a convergent manner where we give one correct answer to things. We try to think one solutions. But in order to design a study, think about the topic, what you need is what we call as divergent thinking, where you give many answers to a single question or many solutions to a single problem. So there are some of methods which you can incorporate to develop this kind of thinking. According to studies, they say, guided fantasies, walking, and everything can actually help you think divergently than thinking convergently. So I think this is very important when it comes to studies. You can think about, if there is a study that's already established, you can think about how else can you design the study? How else can you bring a solution to this topic? So I think this is also quite important. So this is something that you can take a screenshot and keep, where when you do a critical appraisal, these topics need to be addressed. So I'm again bringing you to the summary of the presentation. So you need to understand what p-value stands for. It mainly stands for the chance factor, often observed result. You need to address bias and confounding. If you're reading a paper, you need to read the methodology part very much to understand what is bias and confounding, or have they addressed any of these? Even when you design your own study, you need to keep that in mind. Then you need to read the methodology very carefully. And if you're formulating, you need to be very clear on the research topic. You can advise the PICO method. You need to do an interim analysis to see if there is something. Probably many cases you start doing a study, that's when you realize, okay, what I did was wrong, or probably I didn't need to introduce this particular thing, or I didn't think about this bias or a confounder. So ideally, you have to do an interim analysis when you do your study, and you can actually change or modify your study design according to that. So that's quite accepted. And when you write, you need to write a very clear manuscript about your study, emphasizing what is actually your study adding into the research field. So that is what signifies. So I've come to a conclusion. I think this has actually helped some of you to clarify your ideas or thoughts or knowledge on how to interpret research and how to do design a protocol. So thank you so much.
Thank you, Dr. Singh. It was a very wonderful talk. And I think all the postgraduates should be benefited. And they may not or might not have exposed to such topics earlier. Even if they have exposed, this talk will add on to their knowledge. So I am grateful to you, Dr. Prasim, for your wonderful talk. Thank you once again.
Thank you, sir. Thank you so much. Thank you so much for everyone for patiently listening on a Sunday.
Thank you, all the participants. And in the absence of Dr. Prasim, I have to thank Dr. Prasim on behalf of myself and East West Pharma. Thank you very much. Thank you.
Thank you, Doctor. And thanks for giving opportunity continuously. And this topic is a really is very essential topic. And Madam also has given lucid presentation, and she shared our well-versed experience to our PGs, their benefit. So the so the recorded and edited version is available in our East West Pharma channel. So kindly contact our East West people to get the videos.